Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good day, everyone. My name is Fikri Angara Putra. I'm the engineering manager of PT PGN LNG Indonesia. As part of our PGN LNG culture, I would like to give a bit of transfer knowledge. And for today, it will be about the introduction to process safety. The presentation itself was originally presented during PGN internal conference that focusing on hazardous zone. So the introduction to process safety for this time will be focusing what would the effect on the process safety on the hazardous zone or area. The presentation was developed based on my 10 years experience as a process engineer / process safety engineers in oil and gas field. As a disclaimer, there may be some pictures or tables that I took directly from internet, and please do inform me if or shall you find any possible infringement in the presentation, so I can take down or replace it with something else. A bit of objective and the outlines of this presentation or the knowledge transfer. So basically the objectives is you as the audiences can understand what is the process safety management. You can also understand why the process safety is important. I expect that you can identify process safety in your daily jobs. You would be familiar with study or assessment of process safety. So what you would do to assess the process safety on your plant. And then at the end, you also will be familiar with dangerous or hazardous zone, which based on process safety. The outlines of the presentation for today would be what is process safety, and then what kind of example accident or incident related to process safety, the key items, mitigation, and the example of assessment, what is the timeline of process safety during project, so what kind of assessment you would do during the timeline of the project, the example of process safety studies and assessment, and then the last part would be the relation of process safety with the safety zone, or in this case hazardous zone. Maybe we can start with what is process safety. So process safety basically is engineering and management skills focusing on how to prevent catastrophic accident or near misses in this case that is associated with loss of either containment of energy or dangerous substances, in this case like chemicals on and or petroleum products, and these engineering and management skills exceed those required for managing workplace safety. All in all, if someone should describe what is process safety, what I would like to say is, at the end, we learn or we mitigate how to keep the product inside the pipes and inside the tanks. So basically, the first thing of or the biggest focus on process safety is to keep the product remain inside the pipes and tanks in this case. People sometimes confuse about process safety and personal safety. So what is the difference? Personal safety is basically a typical personnel safety. In this case, is a typical work incident or accident that the consequence would be a limited injuries or fatalities on one person, one or two in this case, and then the effect to the asset would be limited as well, and then limited effect to environment. For example, the personal safety would be falling from height, hit by tools or wrench from above, and then stumbled if you find some obstacles on your pathway, and then it can also be because of fall to a slippery floor or cut injury because of sharp edges. So basically in the personal safety, the consequences would be limited, while in a process safety incident, normally the consequences is either a leak or fire, explosion, oil spills, like what we have in we have a three. I show you three examples here. First one is Bhopal, 1986. What happened was there was a toxic gas leakage called methyl isocyanate. It happens in Union Carbide, India, and it caused uh, approximately, because there was no a real death count on that one, is between 2,800 till 8,000 fatalities. The cost to assess it was 3 billion US dollar damage. The second process safety incident that happens recently, or like less than 10 years ago, it was a Deepwater Horizon in 2009. What happens was there was an oil leaks from one of the pipe. Uh, the leak causing an explosion and very major oil spills. It's one of the worst incident in what happens in oil industry. And the fatalities was 11 fatalities, and it causes 780,000 cubic meters oil spills around the area. The last one that happens in Indonesia was oil spills in Balikpapan 2018. It caused 5 fatalities. Almost 12,000 hectares affected from the oil spills incident. The most recent report says it is suspected caused by a ship anchor that dragged oil pipeline on the sea water level, seabed level. Sorry. So, how to prevent this kind of incident or process safety incident? From the beginning, we need to ensure that we have a safe design. Uh, Basically, on the engineering part, or how to achieve a safe design, we have a control hierarchy. I would like to give you some example of a control hierarchy based on onshore receiving facility station, which basically receive gas from our FSRU in PG and LNG. So the first and the biggest part to achieve safe design is by eliminating the hazard. And in this case, the hazard is natural gas, which is the product that we want to sell. So we cannot eliminate it. Uh, so we need to go to the second step of the control hierarchy, which is basically substitution. And we need to think or to think or to find another solution whether we can substitute the hazard. And in this case, the product that we would like to sell is the hazard. And so basically we cannot substitute it with something else that without any danger on the product itself. So we go to the third part of the control hierarchy, which is basically engineering controls. So basically this is what normally done for mitigate the process safety. So during engineering, we would like to find the best solution on the design. So how we keep the product in the pipelines or in the storage tank. And basically this should be done by the engineers who will design a safe plan. For the example, we will give the sufficient design pressure of piping. So we need to design the pipe with enough thickness. We need to design a pipeline with the correct materials, and etc. We can also put a pressure safety valves or pressure relieving valve on the equipment to ensure that if in any case there is an overpressure on the system, there you can mitigate it not to burst or leak, so it will be directed, the hazard itself, in this case the natural gas, will be directed to a safe location, either it's fan or flare. And there are many other examples that we can do on the engineering control. The next one after the engineering control is administrative control. Basically, we would like to create or develop a system or procedure to ensure that if something not normal we need to do, then we do it in the right way, in a correct manner. In this case, if maybe for an example, we should make a procedure for hot work or procedure to enter a closed containment system or confined space. And then the last one, with the least, let's say, least expected to give as a mitigation, is basically personal protective equipment, because this control hierarchy normally only protect one or two guys, so it doesn't mitigate, or it doesn't give you a barrier for the big consequences. But all in all, everything needs to be done properly, so we get a good design, a safe design, and to mitigate if in any case there is an inadvertent a process that happens in our plant. So a bit more details on the engineering controls. It's a general principles that we need to have an inherently safe design instead of installation of safeguarding. So sometimes we need to increase, maybe it's better to increase the design pressure to the maximum design achievable instead of having a pressure relief valve. That's one of the example. There are a lot of things that you can find on this inherently safe design, but sometimes it's too costly to do that, or it is technically impossible to do that as well. So we need to, as an engineers, we need to choose which one is the best for us for specific for the specific things. And then the second one is we need to ensure that all process condition and any abnormal scenarios is covered by the design or the safeguarding. So sometimes we only focusing on the normal process condition, while there are so many abnormal scenarios that could happen or would happen if something goes wrong. So we need to ensure that we already mitigate for these kind of conditions. And then the equipment design condition shall not be exceeded. This is very clear. But we also need to ensure that no double jeopardy is considered during design. So double jeopardy means that two independent incidents happens in the same time. That is very unlikely. Sorry. The next one is mechanical protection is preferred than instrumented safeguarding. Why? It's because the integrity level of the mechanical protection are normally higher than instrumented safeguarding. And then the last one, but not least, is safeguard. If we implement, or if we install safeguard instrumentation, it need to be fail safe in any case. And normally all these general principles you can find in design guidelines or the equipment specification or any standard provided on your own company. Yeah, but sometimes it's only guidelines and you need to adjust further to the specific case that you find during your job. This is also interesting that Sometimes people ask or we are challenged by, but that is safe enough. This is safe. So what is safe? Um, and when we are allowed to stop to mitigate or stop to find a solution and say, hey, my design is safe. So safe design is just achieved when the risk is acceptable. I would say it again, a safe design is achieved when the risk is acceptable. So how does it define acceptable? Sometimes, or basically, normally, it defined in corporate HSSE framework or by regulation. And then the second one, you may find it in the industrial practice. And then sometimes you need to demonstrate the safeness of your plan by qualitative or quantitative assessment. So this is the upside down pyramid again, uh, showing the risk and the cost, and when it is acceptable for us to say yes, it's safe. There's a jargon says ALARP. ALARP means as low as reasonably practicable. So basically it shows the level of the risk that is tolerable and cannot be reduced further without expenditure, without we expend huge amount or disproportionate cost to the benefit gain, or whether there is no other solution that is practical to implement. So normally we say that is okay, we can go further, but if there's another mitigation that is reasonably uh, from cost point of view is reasonably to be implemented, and we haven't achieved the alarm, we need to implement that barrier, and then we can say that it is alarm. And normally on your if you see the pyramid, the intolerable area, the risk is very high, but the cost is minimum. While in a tolerable, you already minimize the risk, but there is some cost that you need to pay to include those barriers. But all in all, safe design, again, safe design is achieved when the risk is acceptable. This is the example of safety assessment studies. I got it from Wärtsilä during on their technical info sharing session. This is only a typical, it's not really that you should do all the things. Sometimes we as a project or as a company pre-select what kind of safety assessment or risk assessment that we would like to do on our project. As a typical, normally we'll do a HAZOP, HAZID, LOPA or QRA on the design phase or detailed engineering phase, and based on that safety assessment, you will know what kind of mitigation or barrier that you would like to put on your plan. But use this as a guidelines. There is no it is not compulsory to do all. It's based on your own or your company liking or not liking, basically a company policy on what kind of risk need to be reduced. As I say, this is the example of assessment study. It's qualitative. For example, HAZID study and HAZOP and operability studies. Why it says qualitative? Because there is no number. You don't need to count it. There is no number. There is no. It's basically based on the skills of the people who do the assessment. It will says yes, the mitigation is this and this, but then there is you should what is it, you should be able to identify whether the barrier or the mitigation is enough. And then you have a semi-quantitative, it's called LOPA, or layer of protection analysis. This is a mix between qualitative and quantitative. Basically, you would give some kind of numbers on the risk, so how big is the risk, and how the mitigation can uh, can reduce the risk until the residual risk is acceptable by us. And the last typical assessment study is quantitative risk assessment. In this case, you really put a number from the equipment, from the area, and then you will found out that whether from quantitative point of view the risk has been reduced as to uh, our acceptable condition or tolerable condition. I would go fast on this example. Perhaps you may have more experience on doing this. So basically, HAZID is very high level. It's systematic method to identify what kind of potential health, safety, and environmental hazard of a project. And this is typically used in early stage of design because you do not go deep into the design itself. So it's more the surrounding, what kind of the major hazard, what kind of uh, process or project phase that might pose significant risk to personnel. So are there any, or is there any alternative process designs? And at the end, whether there would be a potential major changes to philosophy and design that would be the result of the HAZID. This is the guide words normally will be done during the study. So will there be a process release, and if there is a release, what would the hazard would be, and what is the risk, whether there's an ignition, fire, explosion, or it will be impact on human, and etc. Normally this is a standard guide word, so your HAZID chairman normally go through this, and we brainstorm the people in the HAZID meeting will give their thought, their experience, and give the input to the HAZID study itself. The next one would be HAZOP, Hazard and Operability Studies. This is more deep down. Normally it's based on the PNID of the design, so the real design. And basically it is done to identify all those deviations from the design condition that can lead to accident. The philosophy is to conduct qualitative assessment. The objective is to conduct a qualitative assessment of hazard associated with the operation of a system or facility. And there is a standard approach using guide words, like what I show you in this presentation. So the guide word would be a standard, and normally we go one by one with the note that yes, if there is no flow, what would happen? If there is a reverse flow, what would happen? Or if that's high more pressure, what is the cause, and what is the effect, and when whether there is a consequences. I also show you the RAM rating. I got it from Shell in this case. Basically, it shows what is the what kind of severity or consequences if something happens. So if I say the RAM rating is 5E on the people, so basically there would be more than 3 fatalities because of the safety case, and it has happened more than once per year at the location. This is unlikely to happen. Normally we will see a 5A or 5B RAM rating for the high or the major RAM rating case. The next one will be semi-quantitative assessment. It's LOPA, layer of protection analysis. It's basically it is done to give more assurance for you that safeguards meet independent protection layer criteria. and this is one of the example. I would not go too deep into this. uh, it will be like another 2 days to explain about LOPA, but you get some view basically from this is the initiating event we would put as a frequency, and then every mitigation we will put it as whether the barrier is valid or not, and then what is the failure rate of the barrier, and then at the end whether the residual risk is okay or not. From that, from the LOPA assessment, we will see the safety integrity level assessment, which give confirmation whether all the instrumented safeguarding that we use is indeed okay for the seal that we assume. Another details, but yeah, maybe you can get the point. And then the quantitative risk assessment is basically to estimate the likelihood and consequences from a hazardous event, which is shown by, in this case, very numerical value. So that's why it got the name of quantitative. A risk again is like a consequences time likelihood. So in the QRA, we see consequences modeling. So like a jet fire, how far the jet fire would be, pool fire, how big the area would be from pool, or if it's flash fire or fireball, how big the fireball would be. And then we also do a likelihood analysis. So how likely there is an ignition, and if there's a leak, and then whether the leak will be detected by our system, and then same for fire, and then whether there is a failure of our isolation or fire water, in this case our barriers. And the last one would be if there's some things, and then whether there would be any escalation due to the hazard. This is the example of a QRA. So this is the consequences modeling. The drawing shows how big the impact on the area and how far would it be. Normally the red is the worst case things, and the white one would be it's not impacted by the scenarios. This is a quantitative. This is the likelihood analysis. So basically, we go one by one per cases. At the end, we found out what kind of frequency that would the scenario happens. So if you see the 1 in power minus 6, the probability of 1 to the power minus 6, e minus 6, it means literally or figuratively, it says it may happen one time in 1,000 years or occasion, but this one times can happen 1,000 years from now, or it can happen 1 minute from now. So you need to understand this numerical value. So if it's like yeah, I've been running the plan for 10 years, and I got the probability of 1 to the power minus 6, so there would not be anything happen for the rest of 999,980 990 years from now. That's not true, because if it's probable to happen, it can happen now, tomorrow, or 1,000 years from now. So please use a good description for this. So as I mentioned before, that process safety can lead to zonation of process safety. So this is based on our QRA analysis. So basically it shows for one scenario where is the location, or which one is the least risk. In this case 1 to the power minus 7, you see the green, maybe you can see the green part. This is the safe area, we say, because of one scenarios. So you see on the top left and the top right, if we combine it together, so basically the risk contours from this plan is basically the outside the blue area, the green area, and basically in any of these two cases happen, someone standing, the risk of someone get the consequences uh, on the white zone area is minimum, so it's acceptable. It still can happen that he got injured or the fatalities, but we already accept the risk that uh, something happened to them, because all the residual risk is acceptable. Again, this is a zonation. I already explained it to you that the risk contours perhaps is around 75 meters from the fence, so there should not be anything on 75 meters from the fence. So if we were to what it meant is basically we need to avoid making a plan which is like side by side to a school or church or mosque. In this case, based on this ISO risk contours, it should be more than 75 or 100 meters from the fence. So that's all about the process safety risk. It's not perfect. You can always ask me on the comment section and we can discuss it further. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.